Hello team, and today we're going to talk about the Whyfor of the law of cosines. So it all started with the infamous right triangle. And we learned from the days of Pythagoras that with the right triangle, there's a special relationship between the three parts of the right triangle, where if we define one leg as A, another leg as B, and the third side, or the hypotenuse, as C, and we know that A squared plus B squared equals C squared. The good old Pythagorean theorem. But then we started to ask ourselves, what happens if we no longer have a right triangle? So what if instead of a right angle here, we actually had an acute angle? So that our triangle starts to look more like this. So if we still label these sides the same way, we can tell that the relationship is going to be different now. That side C is now going to be smaller than A squared plus B squared. And so we're going to set up that relationship. A squared, B squared, and C squared. What we know is that this is going to be smaller than that, because when it was a right angle, the slightly larger angle than this, then the sum of those two sides being squared is going to be bigger. Also, if we look at what happens when you have an obtuse angle there, right, so in each of these cases, we're keeping sides A and B the same. When you look at the relationship here, it should be pretty clear that the sum of the squares of A and B is now going to be smaller than the square of C, because the side is so much bigger now, whereas A and B stay the same. Well, what happens if we're looking at this and saying, it seems like there ought to be some way to make it so that all three of these have an equal sign? Now, if we're going to have an equal sign, that means we need to add something to C squared. In order to make it be the same as the sum of A squared and B squared. Here, we can add 0. Right? So C squared is already equal to the sum of A squared and B squared. Here, if we want to make this equal, we're going to need to subtract something from A squared, or from the C squared side, to make A squared plus B squared still equal C squared. In our playing with the numbers, I'm just going to give each of these a random measure. So we'll call this one 27 degrees. Right? We're talking about the angle C now. So here angle C is 0 degrees. Here angle C is 115 degrees. Again, it doesn't matter specifically what these are, but we have an acute, we have, 90, not 0, and 115. Now, if we bust out our trusty graphing calculators, and we take a look at these, if we play around with the different trig options, and we play with cosine, if I take cosine of 90 degrees, I'm going to get 0. Okay, so cosine of 90 degrees equals 0. If I take the cosine of 27, I'm going to get approximately 0.891. Now, if I take the cosine of 115, something really interesting happens. I should get a negative number. So as I'm looking at what we've got up here, I wanted this to be a subtraction. So if I had the cosine of c in here, if it's an obtuse angle, the fact that it comes out as a negative number is going to undo this negative. It's actually turn this into whatever it is, into a positive. So I'm going to replace this with a plus so that when I do the cosine of 115 or something bigger than 90, it's going to end up still being a subtraction from that. In this case, I wanted a positive. I had a positive, so that's fine. In this case, I wanted 0, and this in fact was 0. So if I have something here with the cosine of c in it, it doesn't matter what else I have there, because if I multiply it times 0, it's going to give me 0. Okay, but I'm going to put cosine of c in both these places. Now, through some trial and error and a bit of exploration, we've been able to determine that the thing that needs to be in front of this, because just having 0.891 here is not going to be enough of a difference to really change the value of that. Turns out that the missing component is 2ab. So if I take c squared and add 2ab cosine c, I'm going to get a number that's bigger than what the c squared was, which will bring me back in line with what a squared plus b squared is. If I do 2ab cosine c here for 90 degrees, I get plus 0, so the Pythagorean theorem still holds. Down here, if I do cosine of an obtuse angle, such as 115, I get the 2ab, since a and b are positive numbers, this becomes a negative number. So I do, in fact, end up subtracting there to make this c squared smaller, which will bring it back in line with the a squared plus b squared. So this is just a quick little intro overview to the law of cosines and how somebody figured out that, hey, there's actually this consistent thing that we can add in order to get to the Pythagorean theorem here, in order to make it work for all three different kinds of triangles. I hope that helped.